AMD has this great new platform for AI. So, Rob, before we dive into that, could you tell us a little bit about yourself and how you got involved with this?
Yeah, sure thing, Bill. So my name is Rob Bauer. I'm a senior manager here in the embedded business unit. Been with AMD 4 years now. I actually came over through the acquisition of Xilinx. So my background is in embedded systems, working with customers across a number of different industries, FPGA technology, adaptive SoCs, and now x86. And so from an x86 perspective, right, we're leveraging the AMD technologies across the data center, across client applications, into the embedded markets, right? The core CPU architecture, the GPU architecture, and bringing a new class of compute for embedded customers.
Now, with Xilinx, I actually tried out your Kria SOM, and it was FPGA based. But the new system is based on an X100. Could you tell us what the X100 is?
Yeah, absolutely. So the X100 series is the latest announcement we just made today, building on the Ryzen AI embedded family of APUs. APU, that stands for Accelerated Processing Unit. These devices have CPU, integrated GPU, and NPU. And so when we created X100, we actually had to add a new swim lane to our roadmap for APUs, given the performance that it brings to the table. And really the target applications for X100 are physical AI, any system that really needs heterogeneous processing across CPU, GPU, and NPU, along with high levels of determinism for closed loop control. So think robotics, for example, aerospace applications, automotive applications. This is where this Ryzen AI embedded family really shines. So as part of that, though, we wanted to go beyond just delivering silicon and deliver a platform that our customers can build on. And so to do that, we took the silicon and we actually engaged our ODM partner ecosystem. So all the ODMs that are producing system on modules across the globe for our customers. We defined an architecture by which those partners are designing to be a Kria AI system on module. So now we can go work with all these partners for the system on modules. But beyond that, we've also then created a developer platform that will be sold by AMD. So our customers can have an off-the-shelf solution, turnkey open hardware platform with the software stack for robotics prototyping, and then quickly scale to production using those system on modules.
Well, let's talk a little bit about the platform because it's an industry standard. What is it?
Yeah, so the system on modules themselves, are based on the COM-HPC industry standard. And you'll see different form factors within COM-HPC, Type B, Type C, for example, that our ODM partners are designing to. Right now, on top of that, we've defined a standard for a robotics carrier card that ODMs can build to that break out a number of the different interfaces that people need in robotics.
Well, let's talk about the development system because that module is actually inside there.
Absolutely. So if we look at the developer platform, within there we have a Kria AI SOM, we have a robotics carrier card, which includes a Spartan UltraScale Plus FPGA for additional sensor expansion, sensor aggregation, and fusion. And we break all of that out. And so the robotics developer platform, you see on one side has kind of your standard peripheral interfaces, USB, for example, Ethernet connections. On the other side are the interfaces designed for robotics applications. So things like camera ingest, for example, up to 8 GMSL cameras. We have deterministic Ethernet supporting TSN and EtherCAT, along with high-speed Ethernet up to 4 10 gigabit per second Ethernet connections via QSFP connector. And then, if that wasn't enough, we also have an Oculink expansion connector for PCI Express so that people can bring their own external PCIe cards to expand the connectivity further.
Excellent. Now, that's all the hardware, and it's not just the part of the solution. I should say, it is only part of the solution. Tell us a little about ROCm.
Yeah, so even beyond the hardware. So we have the silicon, we have the SOM, we have the developer platform. But imagine this developer platform shows up at your desk, right? What are you going to do with it? And so to solve that problem, we've actually also just launched a new robotics software suite, which is a full stack. Think about it like Lego blocks that come pre-assembled, right? And so this robotics software suite has everything from the BIOS to the firmware to the physical AI SDK, to your question about ROCm. That is an SDK that will include ROCm support, Ryzen AI support for the NPU, along with various models that have been optimized for embedded. For example, taking industry standard VLMs and VLAs, optimizing the performance to run on our platform. So that's the physical AI SDK, but it will also have a robotics core SDK, which has things like ROS accelerated libraries for ROS2 to enable roboticists that are familiar with that framework to quickly go deploy solutions.
What about the operating system and things like real-time support?
Yeah, it's a great question. If we look at robotics or any real physical AI application, our customers care about more than just peak performance, right? It's not enough to have a high-performance CPU and GPU. What they really need is determinism, because they have to be able to reliably close control loops in these systems. And so to achieve determinism, right, it starts from the silicon up. So from a silicon perspective, the unified memory architecture between the CPU, GPU, and NPU reduces the data transfers between different processes, right? So that's going to help ensure determinism. We also have a significant amount of cache on board this device, over 100 megabytes of total cache across the CPU and GPU. That's going to mean you have less conflict going to external memory, more determinism. But beyond the silicon, there is a huge software component of determinism, particularly with CPUs, right, where you have a finite number of cores and you might have hundreds of threads that are contending for those resources. And so with the X100 series and P100 series before it, all the devices in Ryzen AI embedded family, we're delivering a real-time solution through BIOS optimizations along with Linux kernel patch, the Preempt RT Linux kernel patch set, and then AMD technologies for cache reservation and memory bandwidth allocation mean that our customers will be able to specify, hey, I want these specific threads running on these cores. I don't want any interference from other threads. They're the highest priority. And that's going to help achieve real time. But beyond that, okay, that's kind of the industry standard approach.
Yes.
We've also been leveraging Zen Hypervisor to provide complete isolation. So using free RTOS running in a VM gives complete isolation along with cache allocation technology. So through that, we'll be able to deliver hard real time, which is critical in applications where like a robot's working with a human, right? You can't accept failures.
Exactly. Well, thanks very much for filling us in on the latest from AMD, and I'm sure we'll be talking about more physical AI applications in the future.
Thank you, Bill. I really appreciate the time.